And now after we prepared the geometry for a model, we can now start to create study analysis. So let's go to Simulation tab here, and here we have Study Advisor. So let's click on this arrow, and here we have New Study. Let's click here. Here we have some options. The type of the study we wanna use. We can go with static, thermal, frequency, buckling, drop test, fatigue, design study, nonlinear, linear dynamic, and so on. So in our case, we're gonna use static. So static analysis calculates displacement, strain, and stresses in a body and in the structure under the effect of applied external loads. Those external loads can be forces, torques, temperature, gravity, and so on. So when we use static analysis, we must make few assumptions. So the first assumption is static loading. That means that all loads are applied slowly and gradually, and when they reach their maximum values, they remain constant. And the second assumption is linearity. That means that the relationship between the loads and the responses is linear. So if we double values of loads, the responses, stress, displacement, strain, reactions, will be double as well. So here we can choose static, and here we can change our name. Let's change our name to solid body. And let's click OK. And now we have created a new study, and here we have two trees. The first one is Feature Manager Design Tree that we are familiar with, and the second one is here Simulation Tree. So we have here solid body name, sample B, the name of the part, connections, fixtures, external loads, mesh, and results. And here we're going to add our fixture, loads, and mesh. Here down we have few tabs. We have a new tab, solid body. Here we have motion study, 3D view, and the model. This is the normal part document. So let's go to solid body, and let's go to Study Advisor. Let's click on this arrow, and here we have Study Advisor. What is that? So SolidWorks Simulation gives you a help to guide you through your study analysis. So let's click here. You can use this in preparing your analysis. For example, here you have study. Here you can define bodies and materials, interactions, mesh, and so on. So you can use this as a help to define your fixtures, external loads, mesh, and to interpret results. So for now, we won't use this. We're going to show this later. Let's exit this. And now we are ready to start with our study analysis.